Okay. So in the very last class before Puja vacation, I was discussing about ALU and data path. Okay, I am discussing about what is ALU, what is a register. Okay, now today I will discuss them later on. Okay, I gave a brief idea or brief overview of those registers. Okay, I am again describing those things. Okay, so it will be better that if you will give a new heading in your copy, write down a heading like different classes of CPU registers. Okay, different classes of CPU registers. Give this particular heading: different classes of CPU registers, different classes of CPU registers, and after that draw this particular figure. I am just drawing this particular figure. Okay, please try to draw this. Okay, so please try to draw this. Okay. This is dot dot. Okay, this is dot dot. I'm writing the values. I'm writing the I'm mentioning the names inside those things. Okay, but before that I have to create another thing. I have to create. Okay, let me check for different shapes. Let me check for different shapes. There are okay. Yes. This is shape solution. Let's use line. Let's use line. Let me let use arrow. That will be better. That will be better for this particular purpose. Let us use arrow. Okay, I'm using arrow. You can using by single line. You can also draw using single line also. I'm doing in this particular way. That doesn't mean that you have to also do in this way. You can draw a single line and connect with the this particular box. Here I'm going to write something. Here I'm going to write something that is called main memory. That is main memory means RAM. Main memory. Okay, main memory. Here I'm going to I want to actually discuss yes, last day topic. Okay, once again, because at that day actually I was in a hurry. I was saying lots of things regarding the installation of the particular Java, and also I show you the our simulator. Okay, and for that reason, and that day all of you are not present. Okay, so for that reason I am again discussing this particular topic. Okay, for today this is the entire thing is known as CPU. The entire thing is known as CPU. Here we have ALU, and here we have control unit. Okay, here we have ALU and control unit. Here we have MDR. Here we have MDR. Write down MDR. Here we have MAR. Here we have program counter. Here we have IC. Sorry, IR. IR. Okay, IR. And here you can write R1, R2, R3 dot 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 Rn. Okay, these are the general purpose registers. Okay, you know these terms MAR, MDR, ALU, CU, PC, IR because I told you I introduced some of them some of the name of these registers to you in front of you. Okay. So after drawing this particular figure, please draw this particular figure quickly. Okay. You can pause this video and you can draw it. Okay. And after drawing this particular figure, you can write down the notes regarding this particular topic. Okay. So first of all, write down in computer architecture. In computer architecture, the registers are very fast computer memory. The registers are very fast computer memory. In computer architecture, the registers are very fast computer memory, which are used to execute programs and operation efficiently. Okay, what I told you just right now. In computer architecture, in computer architecture, in computer architecture, registers are in computer architecture, registers are very fast computer memory, which are used to execute programs and operation efficiently. Full stop. Full stop. Okay. There are so many operations that we can perform with the computer. Sorry, with the computer, and performing those operations, we will need or we will use registers. Okay. In general, there are so many different kinds of register, and there are so many different uses of those registers. We are actually studying about those things. Okay. In computer architecture and automation. Now, write down the sole purpose of having register. Now, the sole purpose, that means the main motto, the main aim, the sole purpose of having register is the fast retrieval of data. The sole purpose of having register is the fast retrieval of data for processing by CPU, for processing by CPU, for processing of data by CPU, for processing of data by CPU. Okay, give a full stop. The sole purpose of register having register is a fast retrieval of data, is a fast retrieval of data for processing of data by the CPU. Though accessing instruction, though accessing instruction from RAM, though accessing instruction from RAM is comparatively faster, I suppose that I also told you these things earlier on. Okay, please check, and if you have already written these things, you do not need to write. Okay, but if you do not written these things, please write it down. Okay, so what I'm trying to say is that the sole purpose of having register is fast retrieval of data for processing by the CPU. Full stop. After that, I'm saying that though the info, instruction, though accessing instruction from RAM is comparatively faster with the hard drive. That means if you want to access something from hard drive, it will be very much slower than if you are accessing something from RAM. Okay, so that is I'm saying here. Okay. Mm, After writing hard drive, put a comma, and write it still it still isn't enough for CPU. It's still enough for CPU. That means CPU is very much faster. And whenever CPU wants to access something from hard drive will respond CPU in a very slow manner. And for that reason, CPU will not be properly utilized. For that reason, we have random access memory, that is RAM. Okay. Now, in case of RAM is also slower with respect to CPU, but it can give a response CPU to much earlier than hard disk. It can give the response to the CPU much earlier than hard disk. Okay. Now what happened is that whenever we are dealing with registers, whenever we are storing the instruction, whenever we are storing the data inside the register, now what will happen? As a result, registers are the part of a CPU. You know that registers are the memory unit. Registers are the storage. Registers are the memory which are present inside the CPU, inside the CPU IC or integrated circuit. Okay, inside the CPU chip. Now, whenever you are storing the data and the instruction inside the CPU itself, now the CPU will very much happy. Why CPU will very much happy? Because it can access the data from those registers. It can access the instruction from those registers because they are present in those registers. So for that reason, the processing will be very much fast and CPU can do its job very efficiently and conveniently. And for that reason, what will happen? The main motto will be the CPU utilization. The CPU utilization will be very much high. That means we can utilize our CPU in an efficient way. Okay? Give a full stop. After writing, it still isn't enough for CPU. After writing this particular statement, give a full stop. Okay? Now, come to this particular diagram. Okay? In this particular diagram, what I am trying to say is that first of all, there is a register known as accumulator. I didn't mention that register inside this particular diagram. You can draw here. You can draw here this particular register accumulator. It is one of the most important register. I didn't draw here. So accumulator. Okay. Accumulator. Write down accumulator. Accumulator. Why it is actually used? Why it is actually used? Because whenever CPU performs an operation, at that time, what happens is that at that time CPU will keep one operand in somewhere. Now in somewhere, where? Inside the accumulator. Because whenever ALU performs a particular arithmetic or logical operation, generally one operand will be present at the accumulator. And that's why accumulator is one of the most frequently used register. One of the most frequently used register to store data taken from memory. To store data taken from memory. Okay? And the size of accumulator can vary from processor to processor. Okay? The size of the accumulator can vary from processor to processor. Okay? You can write those things because I'm just saying in a way, in a flow. So the size of the processor will vary from processor to processor. That means, for example, in case of Intel 4004 microprocessor, the accumulator size was 4 bit, for example. And in case of 8085, we have 8-bit accumulator because there the accumulator can contain 8-bit data. For that reason, the size of the register was 8-bit. But in case of basic computer organization, in case of basic computer that we will study, there we will find that the accumulator size length is 16-bit. Okay, 16-bit. So it will vary from computer to computer, and it will also depend on the manufacturer. Okay, the manufacturer will decide that it will be 8-bit or 16-bit with respect to the other components of the processor. With respect to other components of the processor and the work organization that we are actually using, the organization that we are actually following. With respect to that, it will depend or it will vary. After accumulator, I want to discuss about the MAR, memory address register. I hope that you didn't you have forgot those things. For that reason, I am just again revising this in this particular class. I am just revising those things again. Okay, because we have to write some programs, and for that reason, these are the concepts you have to know very much in a clear way. So memory address register. In case of memory address register, what it will store? It will actually hold the address of the instruction to be accessed from memory. To be accessed from memory. Memory address register, it will hold the address of the instruction. That means in memory, in RAM, where your address or where your instruction is located. In which location? In which location your instruction is located, that particular address will be held by this particular register, memory address register. I am discussing this register MAR, MDR, PC, IR, R1, R2, R3 for example. So these I am discussing all these registers with respect to basic computer organization as per your chapter, as per your book, Maurice Mann, as per your syllabus. So it will vary from processor to processor in real life world. Okay, in real life for processor i3 or i5, i7, it not be MAR or MBR or it not be MDR. It might be other thing, but the functionality will be the same. Because the basic all the computers which are actually we are using right now are based on the architecture. They have some architecture in common that we will study in our syllabus. So what will happen is that whenever we are actually using MAR is actually used to hold the address of the instruction that is located in memory somewhere. Okay, and another thing I want to mention is that MAR and MDR. MAR and MDR. Remember the listen carefully. MAR and MDR. Memory address register and memory data register. Okay, together facilitate the communication of the CPU and the main memory. The communication of CPU and the main memory. The communication that occurs between the CPU and the RAM is actually dealing with these particular registers MAR and MDR. Okay, and after MAR I am coming to MBR or MDR, whatever you can say, memory data register or memory buffer register, or sometimes it is also called data register, DR. Okay, DR. Now what is MAR or MDR? It is actually containing the data. Okay, it is actually containing the data of the location which is held by the MAR. That means the register MAR holding the address of particular location, and in that location whatever the data will be there or whatever the data will be present, that data is going to be held by MDR or MBR. Data on which data we are actually working. In the current instruction on which data actually we are working, that will be held by MDR. Okay, that will be held by MDR. Okay, now after MDR I am coming to the program counter. I already discussed about program counter. Okay, in case of program counter you will find that program counter is a register. It can, and it is basically categorized as a special purpose register. Okay, in some processor, for example Intel 8085 microprocessor, program counter is fall under special purpose register. Why? Because it serves a special job. What is the job of program counter? The job of program counter is to hold the address of the next instruction to be executed. Suppose you are executing a particular program, and in that particular program, suppose you are executing a C program, and in C program there are 10 instructions. Suppose there are 10 instructions out there. Okay, now those 10 instruction will be located in the memory, or in the RAM, and CPU will fetch each of the instruction one by one. It will fetch each of the instruction. Now program counter is a register which will actually hold the address of the next instruction to be executed. That means suppose you are writing a program and you are executing the program, and your program contains 10 instructions, and at current time you are actually executing the instruction 5. Instruction 5 is getting executed by the CPU at present time. Now, so program counter will hold the address of instruction 6. That means program counter hold the address where the instruction 6 is located in the memory. Where the instruction 6 is located in the main memory, that means in the RAM, where it is located, it will hold the address of that, so that whenever CPU will finish I5, that means instruction 5 execution, whenever CPU will finish its execution of instruction 5, at that time CPU can start execute its I6 instruction. So for that reason, program counter serves a special job. So that's why in 8085 we actually call it is as a special purpose register. Here you can also call it as a normal register, special purpose register, whatever you can say. Okay. Now after program counter come to IR, instruction register. Okay. After program counter come to IR. Now what is IR? What is IR? IR is the instruction register. Okay. Whatever the instruction I told you, I didn't told you. Suppose I told you in other classes. Okay. Uh, what actually happened is that whenever you are providing an instruction, generally that particular instruction, according to the particular instruction, there will be an, suppose you are executing add instruction. So suppose you are executing an add instruction. And corresponding to the add instruction, there is a numeric code. Or number associated with that instruction. Suppose the number associated with that instruction is 32, for example. That means if you provide 32 to the computer will understand that it will perform addition operation. Okay. If you provide 32, okay, to the computer will understand it will perform addition operation. Okay, it will perform addition operation. So IR is going to store the numeric value of the instruction. That means IR is going to store the operation code. You can say that operation code of the instruction. What is the operation code of a particular instruction? Every instruction will have a particular operation code. Particular operation code, and that operation code is going to store inside the IR, inside the instruction register. Okay, so you can write in this way also. The IR holds the instruction which is just about to be executed. Means whatever the instruction CPU will start of its execution. That means CPU wants to start the execution of this particular instruction. Okay, that particular instruction operation code will be there, will present inside the IR. And what CPU will do? CPU will first decode the instruction. That means CPU will first give the numeric code or operation code of the add instruction to the instruction decoder, so that CPU can understand whatever the operation it has to perform next. That means it has to perform addition or subtraction or multiplication or division or any logical operation or whatever it is. Okay. So after decoding, after reading, after parsing, whatever you can say, whatever the meaning, what is the meaning of that operation code? That CPU wants to know whatever the meaning of the particular instruction. For that reason, the operation code is going to be stored inside the IR. Okay, inside the IR. Another thing you can write is that as soon as the instruction is placed inside the IR, the CPU starts executing the instruction. And the program counter points to the next instruction to be executed. Okay, next instruction to be executed. This is the thing that I have to say. After IR, coming to the general purpose register. After IR, I am coming to the general purpose register. Okay. So in case of general purpose register, there can be so many general purpose registers are possible. It will depend on the manufacturer. Okay, the number of general purpose registers that actually they will give, it will depend on them inside the CPU. It can be 8, it can be 10, it can be 16, it can be 32. The general purpose registers can be possible because it is totally depend on the in manufacturer. If manufacturer wants to give more general purpose register, then they can give, but the cost will increase. If the number of register will increase inside the CPU, then automatically the cost will increase. Automatically the cost will increase, and in case of general purpose register, you can write in this way also. You can take a short note. Basically, they are in basic computer organization. In basic computer organization, that means you are whatever you are studying, they are named with R1, R2, R1, R0. Here I didn't mention R0, R0. That R0 also termed as R0. Okay, R0, R0, R1, R2, dot dot dot, Rn. Okay, generally we use in this way in basic computer organization. But in case of real world, for example, suppose we have a processor called 8085 microprocessor. Why I am saying again and again for 8085 microprocessor? Because 8085 microprocessor is the one of the best microprocessor through which you can actually understand the computer architecture in very efficient way. This is the most eminent processor among us, a product from Intel. Okay, in that microprocessor, there are generally six. There are generally six general purpose registers were there. They are named as not R0, R1, R2, R3. They are named like B, C, H, L, D, E in this way. B, C, D, E, H, L. These are the six general purpose registers were there in 8085 microprocessor. What is the use of those registers? The use of those registers is actually whenever we will perform some assembly language programming, at that time we will going to use them in our programming, and we are going to store some information, we are going to store some data inside those general purpose registers, and then we are dealing with those things. Now you can write another point. Okay, you can write another point. Right, modern CPU architecture tends to use more general purpose registers, so that so that the data accessing and the processing, data accessing, that means data retrieval, and data processing by the CPU can be done in a convenient and efficient way. So for that reason, we are actually having this much of registers. Okay, but what I told you just right now, that I told you that whenever we are having so many general purpose registers, the cost will automatically increases. Okay, the cost will automatically increases. So for that reason, uh, but right now actually what I said, right now we are actually investing on the cost, but that means the cost right now nothing matters. Okay, we want to perform CPU much more efficiently, much more faster. So for that reason we are also happy with the cost. Okay, we are also happy with the cost, and we are also investing money on the processors. So for that reason we are getting the processors like AMD Ryzen, we are getting the processors like Intel i9, Intel i7. These are the very much high-end processors we are getting, and we are actually creating our workstation at our home, at our office. So we are actually using, because whatever the operations that we are actually performing right now, whatever the workload we are actually giving the computer. So for that reason, we have to have a processor with a higher capability. Otherwise, our system will not give that much efficiency, that much convenient uses. So for that reason, we are also actually having this much of registers inside the CPU. And the point that I told you, the data accessing and data processing. That is the most important point. Okay. After this, what I will say about that, there are so many registers are there. I hope that you have understood these things, this diagram. Okay. And there is also called CU. CU is the brain of the computer. CU actually, what control unit. What control unit actually performs? Control unit actually performs is that control unit actually generate control signals with respect to the operation code. With respect to the operation code, it will generate the control signals. Okay. By using the control signals, ALU will perform the particular operation. ALU will perform the particular operation, and with respect to that operation, the CPU, that means ALU will execute the task. Okay. That means after decoding the instruction, whatever I am saying that you are giving the instruction operation code, and whenever the CPU is decoding that operation code, now it is the responsibility of CU to generate the control signal with respect to those instructions. With respect to those instructions, CPU will generate the control signals, and those control signals will come to the ALU, and ALU will perform the job accordingly. Okay. So for as I'm not present in today's class, so for today's class I will keep these things, and I will give you the revision, and I will give you some time to revise all those things. And in this time, this after this time, you should practice, or you should go through those all the notes I've given, and the notes on number system. Okay. On number system, I also told you, so there are so many different things about the complement, B's complement, B minus 1 complement, radius complement, diminished radius complement. Okay. Please go through those things, and if you have any kind of doubt, please ask me in the comment section for today's class. In classroom, in Google Classroom, please ask me, or you can generally it is better if you ask me some questions on classroom. I will give you the answers on the next day or in the classroom itself. Okay. So for today's class, as I am not presenting here, I am not taking the class as on live. So here it is a recorded session that I gave you, of 35 minutes or 34 minutes. Okay. The remaining portion, the 15 minutes, the remaining next 15 minutes, it is for your evaluation portion. I will give you some questions. I will give you some questions for this particular 15 minutes, that assignment, a short assignment. You have to perform those questions within 15 minutes. Okay. I will give you 15 minutes, and please upload those assignment after this particular class, or please post your answer, because they are very much easier questions with respect to the things that we have studied already. That means the number system, and and on this particular topic. Okay. What I discussed right now, some questions I will give you in the classroom. Okay. I'm giving I already I will give you in the classroom, and you have to answer those questions within 15 minutes, and upload it after 15 minutes. Okay. So this is a revision class after puja vacation. So I hope you have clearly understood. If you have any doubt, then you can ask me on the next class, or you can ask me on the this particular class also. Okay. So I'm stop recording.